Screen printing is an important and growing segment of the vast graphic communications industry. Recent data from the industry reveals that sales in the screen printing industry total approximately $13 billion annually. The industry is keeping pace with the rapid technological developments that characterize the entire printing industry, and that fact is confirmed here with video footage from the New Orleans SPAI convention. Screen printers may keep up with the latest developments in their profession through SPAI, its publications, seminars, and trade shows. This video cassette is the second in a series of 2 cassettes which are intended to introduce screen printing materials and supplies, along with information regarding their use to students and to beginners in the industry desiring to learn about the process at an introductory level. Topics to be covered are inks for specific printing purposes, screen fabrics and their purposes, stencil preparation, and screen printing squeegees. Basic hand procedures are used for demonstration purposes in this cassette. Another introductory video cassette covers making and preparing frames, stretching screen fabrics, materials and supplies, and printing and cleanup procedures. Because the applications for screen printing have become so diversified, the inks, solvents, screen materials, and supplies used by screen printers have become very complex. The selection of the specific materials to be used is determined by the substrate to be printed upon, the purpose and use of the printed product, and the quality of the printing required on a specific job. The screen printing process uses a wide variety of inks, primarily because the process is used to print on many different substrates for a variety of uses. The ink must flow easily, print well, dry quickly, and be durable, scuff resistant, weather and light resistant, chemical resistant, and compatible with the substrate on which it is printed. These requirements place exacting demands on the ink manufacturer. Screen printing ink manufacturers supply ink for general printing on poster and paper products. Color-fast inks must be used for outdoor advertising displays. Enamel and lacquer inks are used for many industrial applications on paper, wood, leather, metal, and decals. Textile inks print directly on fabric, while heat transfer inks are printed on transfer paper for later transfer to textiles. Heat applied to the transfer paper causes the ink to transfer to the fabric. It has been necessary for ink manufacturers to develop special inks to adhere to the many different plastic materials which have been introduced. These inks include those developed for vinyl, polyethylene, polystyrene, polypropylene, polyester, polycarbonate, acrylics, and acetates. Etching resists are for use in the production of electronic circuit boards to block out areas on the board which should not be affected during the process of etching. Special inks are produced for the ceramics industry, for decals and direct printing applications. Ink manufacturers are developing many new environmentally safe inks for use by the industry. Water-based inks are one example of these efforts. Ultraviolet or UV curable inks have been developed for screen printing. The fluid ingredients of these inks are converted to solids, which minimize the amount of pollutants discharged into the atmosphere. The variety of inks used in the screen printing industry require compatible solvents. Before using solvent and ink products, the material safety data sheets should be reviewed. Adequate safety precautions should be followed when using inks and solvents. Oil-based inks use petroleum solvents or mineral spirits for thinning and cleaning. Lacquer-based inks require lacquer thinner as a solvent. Each of the other ink products have specific solvent requirements. The purpose of a screen material is to hold the elements of the screen printing stencil together during the printing process. While it is holding the stencil elements together, it must also serve some other functions as well, such as maintaining accurate registration of the stencil from sheet to sheet, providing a reservoir for ink during the printing process, supporting a mask for non-printing areas, and supporting the squeegee. Though many fabrics can do these jobs, some are more useful than others. Organdy is an inexpensive fabric that is often used in schools. It has a coarse weave compared to other screen materials, so it is not suitable for extremely fine line work. However, for some applications, organdy is a useful screen material. Silk has non-uniform multi-filament threads, which are fine threads twisted together. It is especially suited to easy adhering of hand-cut and photo stencils. Silk is gradually being replaced with synthetic fabrics. Nylon, a monofilament material made from single strands of man-made fibers, adjusts well to rough, uneven surfaces. It must be stretched until it is very taut. Polyester is a multi-filament material which is more uniform and durable than silk. Multi-filament fabrics can be woven with 20 to 225 threads per inch. Monofilament polyester provides excellent registration and dimensional stability. It has very little stretch. Monofilament fabrics can be woven with up to 500 threads per inch. Metal-plated polyester is a metallized monofilament material which is durable and resistant to abrasion and has minimum stretch. Stainless steel provides the best registration obtainable. It does not stretch and is extremely durable. The mesh opening of a fabric is the space between the threads. Listed here are many of the factors which influence the selection of a fabric. They are color, mesh opening, or the percent of open area for printing, fabric thickness, thread diameter, tensile strength, resilience, elasticity, moisture absorption, abrasion resistance, registration accuracy, resistance to sunlight, chemical resistance, and the amount of ink penetration in the fabric. Screen printing stencils may be hand-drawn, hand-cut, or made photographically. Stencils for screen printing may be drawn directly on the screen with tuche or other similar material. The screen is then coated with water-soluble glue and dried. Mineral spirits dissolve the tuche, leaving open printing areas, while the glue masks non-image areas during printing. Ink-resistant paper stencils are often the most efficient and economical means of producing stencils for large display, short-run work. It is relatively easy to produce paper stencils when the work is large-scale. After the stencil is produced, the paper stencil can be placed on a flat surface using very small amounts of adhesive to hold the stencil in place prior to adhering it to the screen. The stencil is adhered to the screen with the ink used to print the job. Then the job can be printed. Hand-cut stencil materials consist of a thin film coating adhered to a support sheet with release cement. The three general types of hand-cut materials are pyroxylin film used with mild solvent ink, acetate-coated film for lacquer-proof applications, and water-soluble films for strong solvent applications. All of the films are hand-cut the same way, but each stencil material requires a different solvent to adhere it to the screen. To cut a stencil, the artwork is placed under the film material. It can be easily seen through the film. A sharp knife makes clean, concise cuts on the film. It is sometimes easier to let the cut extend farther than the lines of artwork so that the film material to be removed may be completely separated from the material that is to remain on the support sheet. A sharp knife blade requires minimal pressure to do the work of cutting through the film to the support below. The use of pressure will cut through the support, making the task of film removal difficult, which defeats the purpose of the material. Photographic stencils use photographic negatives and positives, or hand-prepared substitutes to expose a light-sensitive stencil material. Light striking the material causes it to harden, while areas protected from the light will be unaffected and can be removed. Anything which blocks out the exposing light can serve the same purpose as a film negative or positive. Several types of photographic stencil materials are available. The type selected for use is left to the printer to determine based on the type of work being done. It is important to remember that exposure tests should be made on all light-sensitive photographic materials to determine the best exposure for the light source used. Unsensitized films must be sensitized prior to exposure to light. Carbon tissue was one of the first photographic stencil materials used, but it is not used frequently today. It is sensitized in potassium bichromate, dichromate, or similar sensitizer at a temperature of 68 degrees, then adhered to a mylar support and exposed. The edges should be masked 1/4 inch on all sides to allow easy removal of the backing material. The stencil is soaked in hot water at 110 to 125 degrees temperature until the paper backing releases, leaving the stencil on the mylar. Excess carbon tissue is washed from the image area. The stencil is cooled to 68 degrees and adhered to the screen. When it is dry, the transfer to screen is complete and the mylar may be peeled off. The screen is masked and the stencil is ready to print. All safety precautions should be strictly observed when handling bichromates and dichromates. Their use as a sensitizer is rapidly diminishing. When direct emulsion is used for a stencil, sensitizer is mixed with the direct photographic emulsion just prior to application, and the emulsion is then flowed directly onto and into the screen mesh in a thin, even coat. If coverage is not adequate, another coat may be applied after the first one dries. When the direct emulsion is dry, it can be exposed. Image areas will wash away and non-image areas will harden with exposure to light, forming a mask to block the ink in non-printing areas. In a commercial production setting, the direct emulsion stencil is very easy to work with and is frequently used. In situations where photographic emulsions are not used on a regular basis, direct emulsions are not as desirable. Automated systems, such as this one, can apply the direct emulsion with greater accuracy and consistency. The chief difference between this type of emulsion and the indirect type is that the screen printing frame must be managed during the exposure of the stencil. Equipment is necessary for maintaining good contact between the film positive and the sensitized screen during exposure. Pre-sensitized indirect screen films are films which consist of a thin layer of sensitized emulsion on a thin acetate base support. The film is exposed and developed in a developing solution and then washed with hot water to clear the printing areas. The resulting stencil material is placed under the screen and blotted into the screen mesh. When the stencil is dry, the acetate support is removed. The non-printing areas are masked and dried prior to printing. To achieve certain results, it is sometimes desirable to combine best features of the direct and indirect stencil materials. When this option is chosen, the indirect stencil is applied to the screen and then adhered or sensitized with a coating of direct emulsion. Direct, indirect films are available sensitized and unsensitized. They consist of a film on a support base which is adhered to a screen. If the film is unsensitized, a sensitizer such as diazo is applied prior to drying and exposure. If the film is already sensitized, it is adhered, dried, and the support base is removed prior to exposure. The shape and hardness of the squeegee blade vary according to the type of ink and the substrate being used in a particular job. Squeegee blades are usually 3/16 to 1/2 inch thick and project from the handle 3/4 to 1 3/4 inches. Squeegees vary in length depending upon the size of the frame. Industrial squeegees can run up to 12 feet in length. The flexibility, strength, and chemical resistance of the blade selected for use will vary according to the requirements of a particular job. Hard blades leave a sharp, thin layer of ink, while soft blades deposit a fairly thick pigment layer. Blades with a medium hardness are used for most general work. Several blade shapes have been developed for printing on different substrates. Square-edged blades are used for general printing on flat surfaces. Rounded corners on a square-edged blade leave extra heavy ink deposits for printing light colors on dark backgrounds or for printing with fluorescent inks, while a rounded edge is used for heavy deposits of ink on textiles. The single-sided bevel edge is used for printing on glass and nameplates. A flat-point, double-sided bevel edge is needed for printing heavy ink deposits on ceramic materials. The V-shaped double-sided bevel-edged blade is ideal for printing on uneven surfaces such as bottles, mugs, and other containers, as well as for delicate textile designs. Today's screen printer takes full advantage of the diverse technology of this industry by considering the requirements of each individual job, and then selecting the inks, solvents, fabrics and stencils, and equipment best suited to those requirements. This video cassette has dealt with some of the more important items required for screen printing. But the industry is large and complex, and there are many more materials and supplies that are very useful and help make the printer's job easier. Screen printing industry manufacturers and suppliers have developed and accumulated a vast amount of information on screen printing products. Their publications are recommended for knowledgeable and safe use of the products.